Today's video is going to cover how to handle significant figures with calculations. So previously, you learned how to recognize significant figures. Now, just as a bit of review, remember why significant figures are important is that whenever a piece of equipment is used to collect data, to measure data, that piece of equipment has a certain accuracy. And we need to take that into account when we do any calculations with that data. There's an old saying in industry, across many industry, is garbage in, garbage out. So if you have data that isn't very accurate or good, well, the results you would get from any calculation using that data is also not going to be very good or very accurate. So, how you handle significant figures in calculations depends on what mathematical operation you're doing. So the first ones we'll be looking at are when you multiply or divide, will round your answer to the same number of significant figures as the measurement with the least number. Okay? What that is basically saying is that the least accurate measurement you have, that will determine how many significant figures you can have in your answer from the calculation. And you're just looking at the least number of significant figures. Okay, that's very important because when we get to addition and subtraction next, it's different. So for example, if we're looking at this data here, student went and measured something, 3 measurements. You got a 3.2 centimeters, a 3.65 centimeters, and a 2.05 centimeters. Hopefully you can understand that this is the least accurate measurement. And the reason for that is this number here, 3.2, as written, only has 2 significant figures total. This one has 3, and this last one also has 3. Because remember, this 0 in the middle, because it's sandwiched between 2 non-zero numbers or 2 significant numbers, becomes significant. So this has 2 significant figures, this has 3, and this is 3. So when we do our calculation, try to get that so the glare is not in the number, take 3.2 times 3.65 times 2.05. Your calculator is going to give you that, 23.944. Now, hopefully, it makes sense to you that you would not be able to report 23.944 with any confidence that that is the exact number based on these measurements. Because likewise, this was measured on a ruler that could measure the nearest tenth of a centimeter. These two worked in the nearest hundredth. This answer here is to the nearest thousandth of a centimeter. In this case, cubic centimeter. So, when we're looking at this, remember this has 2 significant figures, this has 3 and 3. So the least accurate value, the least number of significant figures, is going to dictate how many significant figures our answer can have. So our answer can only have 2. So that means we have to round this value to only have 2 significant figures. And the easiest way to do that is typically start on the left of the number and count over 2 spots. 1, 2. So we need to round this to the nearest 1. Right? So in order to see if we're just going to make this 23 or just 24, we have to look at the number next to it, and it's a 9, which is greater than 5. So we're going to round this up to 24 cubic centimeters. So this is the same number of significant figures as the measurement with the least number. Okay, so multiplying and dividing, you're only concerned with what piece of data has the least number of significant figures. Now, get a little bit of practice with this. Again, all of these examples A through 8 are just going to be using multiplying and dividing and use the same rules for both operations. So with this next one, 23.4 times 293.3, your answer gives you this number, which has all sorts of significant figures. But we have to look at which one has the least number of total significant figures. This one has 3, and this one has 4. So our answer has to be rounded to 3 significant figures. And that means that if we count over from the left, 1, 2, 3, we have to round to the nearest 10. Turn that light off for less glare. So we're going to round to the nearest 10. So we look at the value behind it. It's a 3. It's less than 5, so we're just going to round down or truncate. So that means this answer would be reported as 6860. As written, this 0 here is not significant. Go on to the next one, 0.0004 times 0.00053. Calculator gives you this. Now we need to figure out how many significant figures are in each of these. Hopefully this one, all these zeros in the front are placeholders. So this, as written, only has 1 significant figure. This one has 2. So our answer only can have 1. So we are going to, in this case, since it's a number smaller than 1, we only have 1 significant figure, so this 2 is where we have to round it to. So we look at the number behind, it's a 1, so we're just going to round down or truncate. So we would either write that 0.0000002, or we put that in scientific notation. Here, I'll just write that down, 0.6 zeros, 1, 2, 3, 4, 5, 6, and a 2. We haven't covered scientific notation yet, but that'll be topic for the next video. But if you were to put the scientific notation, it would be just 2 times 10 to the minus 7th. Okay, moving on to the next one. 2300 times 98,000. Calculator gives you that. Then we need to look at the numbers. This one here only has 2 significant figures. This one only has 2. So your answer can have 2. So counting from the left, 1, 2. Got to round it to this spot. We look behind it, and that's a 5, so we're going to round this up to a 3. And then this is also another very big number. It'd be very handy to put the scientific notation. But it's going to have 3, 6, 7 zeros, and then a 2 and a 3. 1, 2, 3, 4, 5, 6, 7. So that is going to be 230 million. Okay, we're going on to the next one. Just looking at significant figures first. This has 5, and this has 3, because the 2 and the 4 are significant, makes the 3 zeros that are sandwiched between them significant as well. So it would be 20.004 times 9.2. Oh, sorry, 4.92. So the answer says this. And we have to round to the least number of significant figures, which is 3. So counting over 1, 2, 3, going to round to the nearest 10th. Look at the number behind it, it's a 1. So that's just going to be a 98.4. Now up here, this has 4 significant figures, this is 5. And it's now division. Same rules though. 7823 divided by 29348. Calculator gives you a whole string of things. They can only have 4 significant figures. The 0 over here is a placeholder, so we need to count over from this value here, 1, 2, 3, 4. So we've got to round to the nearest 10,000th. Look at the number behind, it's a 5, so this is going to get bumped up to a 6. So 0.2666. Going on to the next one. This has 3 significant figures, this only has 1. So our answer can only have 1 significant figure. So we have to round this to 1 significant figure. And there's our first significant digit in this number. We look at the number behind it, it's a 7, so we're going to round this up to a 9. And now the only digit we'll have, 0.5 4 zeros, 1, 2, 3, 4, and then a 9. This next one, this value has 4 significant figures. This value, as written, only has 3. So when we do this operation, we have to round to only 3 significant figures. So there, divided by 10.01. To 3 significant figures, counting from the left. Since this is a number bigger than 1, 1, 2, 3. Look at the number behind, it's a 0, so this just stays as a 2. And how many zeros is that? 1, 2, 3, 4. 4 zeros. So that's 9,220,000 would be the value. Then finally, this value here has 3, this has 2. Right, these zeros there are placeholders. So 36, 34 divided by 1, 2, 3, 4, 5, 4. Again, your calculator does not know how to do significant figures, and it cannot do significant figures for you. That's where we have to come in and do it for us. So counting from here, 1, 2. We look at the number behind the 4, it's a 7, so this is going to become a 5. And how many numbers? 3, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7. So 150 million. Okay? Now, when adding and subtracting, now we're switching gears. The answer should be rounded to the same place value as the number with the least precise value. What that means is that when multiplication and division, which we're doing up here, all you're concerned with is the least number of significant figures. In addition or subtraction, you're looking for the thing that has the least accurate place value. So, look at our example here. 3 measurements again. Right? If you're looking at it and we're adding together. So basically, what this is telling me when I'm looking at this data, this value was measured with a ruler that could read only to the, or a measurement device that was only accurate to the nearest 10th of a centimeter. This value here, much more accurate ruler, could read to the nearest 1,000th of a centimeter, and this one was in between, could read to a 100th of a centimeter. So when you add these 3 together, the measurement that was recorded with the least accurate place value is going to basically dictate how accurate your answer from this calculation can be. So we're looking at place values. This number here, like I said, is accurate to the nearest 10th of a centimeter. This number here is accurate to the nearest, accurate 1,000th of a centimeter. This one to the nearest 100th. So this number here is going to dictate how accurate our value is. It was the least accurate number, where it was only accurate to the 10th spot. So when we add these 3 values together, we have to round to the nearest 10th spot. So 28.0 plus 23.538 plus 25.68. Your calculator says 77.218. But we have to go to, in this case, since there's decimal places in all 3, we have to go to the least number of decimal places, which is 1. So we're going to round it to the nearest 10th, which is 2. We look behind, it's a 1, so we're just going to truncate it. So we'd say it's 77.1 centimeters. Okay? So let's get some practice. So if we're looking at this first one, right, we're not looking at total number of significant figures. We're looking at the least accurate place value in one of these numbers. This is accurate to the nearest 100th. This is also accurate to the nearest 100th. So when we add these 2 values together, it can be reported to the nearest 100th. So now we would be able to say that that is 12.93. One interesting thing about significant figures, when you add or subtract, your answer can end up with more total significant figures or less. When you Multiply or divide, however, though, you can't lose or gain significant figures. But addition and subtraction you can, because you notice we went from 3 total significant figures in this number and 3 here to our final answer here has now a 4. But remember, adding, subtracting, it's not about total significant figures, it's about the place value. And since these are both accurate to the least place, the same place value, then we can go from there. Next example. This number here is accurate to the nearest 100th. This number here is only accurate to the 10th. So our answer can only be reported to the nearest 10th. We have to round to the nearest 10th. So 12.3 plus 9.34. You get, that is calculation here. 9.34 plus 12.3. Calculator says 21.64, and we have to round it to the nearest 10th. So we look at the number behind, it's a 4, so we're just going to truncate it to 21.6. This next one, this number is accurate to the nearest 1. This number here is accurate to the nearest 10,000th. So when we add these two together, we have to round it to the nearest 1. Oops, no. 8302. 99.3423. So calculus is this, but we have to round to the nearest 1, which is this spot. So we look at the number behind, it's a 3. So this just stays at 8401. Let me rewrite that. 8401. Now this number, add them together. This number here is accurate to the 10,000 place. This number here is accurate to the 100 place. Of the two numbers, this is the least accurate place value. Right? These 4 zeros here are placeholders. They're not significant. If there's a decimal place here or a line over one of these zeros, then that zero would be considered significant, but there isn't. So when we add these two numbers together, we have to round it to the nearest 10,000. So it's kind of 38200. And we have to round it to the nearest 10,000, which is the 5 spot right here. So when we look at this, it's an 8, so we can round it to a 6. So that would be 386. 0, 0, 0, 0. Where do I want to put this? Okay, this next one. This is accurate to the nearest 100th. So is this. So when we do this, 2 point. Now we're doing subtraction. Same rules though apply. You notice your calculator says -6. But this number we need to express this that it is accurate to the nearest 100th. So what we do there is that becomes a -6.00. 2 decimal places here, our number needs 2. Next one here, this is accurate to 4 decimal places. This one's accurate to 5. So the least accurate is 4. So we're going to have to round it to 4 decimal places. 0.0032 minus 0.00033. 4 decimal places, that would be the 8. So we look at the number behind it, it's a 7, so we're going to round that up to a 9. So 0.0029. This next one, this is accurate to the nearest 100th. This is accurate to the nearest 1. So this is the least accurate place value of those two numbers. So they are going to have to round to the nearest 1. So we get 550.92. Need to round to this spot. So we look at that behind it's a 9. So we bump that up to a 1. And lastly, we're going to look at this. Notice this is accurate to the 100th place, or 2 decimal places. This is accurate to to the nearest 1 million, or to the near millions place. This highly inaccurate number. This somewhat accurate. So this, we have to round this, when we do the subtraction, we have to round to the nearest million. So 3, 8, 1, 2, 3, 4, 5, 6, minus 383.25. Rounding to the nearest million is a 7. We look at the value behind it, it's a 9. So we have to bump this up to an 8. 1, 2, 3, 4, 5, 6. So you notice, because of how inaccurate this number was, this 38 million, if we subtract a small value from that, due to significant figures, the number doesn't change because of how inaccurate this is. Because this is, we have to round to the nearest million. So in order for this to even register, we'd have to almost subtract close to 1 million from it in order to say that this number's changed whatsoever, because of how inaccurate that is. Okay. Now, going on to what happens when we have mixed calculations, when we are mixing operations, such as multiplication and addition, or either multiplication and division and addition and subtraction. When we mix those two different type of operations, then we have to follow the order of operations and take significant figures after each level of operations. This is where it gets a little more complicated, because when we're looking at this equation here, you notice we have addition and division. So those are two different rules. So we have to take it one step at a time and follow order of operations. In mathematics, an order of operations says we are going to do this addition that's inside the parentheses before we do the division. And we have to apply the rules for addition to this. Right? We're adding this plus this plus this. This is accurate to the nearest 10th, so is this. This is accurate to the nearest 100th. So when we add the three things in parentheses together, we have to round it to the nearest 10th. So this becomes 26.85. We have to round it to the 10th. So we looked at the number behind, and that's a 5. So this gets bumped up to a 9. So now this basically becomes 26.9 meters divided by 8.88 meters. So 26.9. Now we've shifted gears. We've gone from addition now to division, and the significant figure rules also change. We're just concerned with the least number of significant figures. And the 26.9 has 3, and this has 3. So our answer, when we divide these two, will have 3 total significant figures. Divided by 8.88. And for 3 total significant figures, we start at 1, 2, 3. The 2, we look behind it, it's a 9, so we're going to bump this up to 3.03. With addition, when we mix operations, and most commonly you will see this in class when we're doing percent error. Or if we're, when you do percent error, you're mixing operations. You're doing subtraction with division. And so that makes getting the correct number of significant figures with that particular formula a little bit more challenging than just straight addition or multiplication. Okay, we go on to the next one. Got this 150 minus, and then you've got these numbers in parentheses with a division symbol. So order of operations says we do this in the parentheses first. And this has 6 total significant figures. This has 4. So when we divide these two, our quotient, so to speak, for this can only have 4 total significant figures. So we've got to round it to 4 significant figures after we do this. 234.27 divided by 63.23. Calculator says that. Count over 4 spots. 1, 2, 3, 4. Look at the number behind it, 0. So we're just going to truncate it. This becomes 3.704. Now, this basically becomes 150 minus 3.704. Shifting gears, now we're doing subtraction. This number is accurate to the thousandth place. This number here, as written, is only accurate to the nearest 10. So when we do the subtraction, we have to round it to the nearest 10. So here's the 10 spot. Look at the value behind it, it's 6. So we have to round this up to a 5. So just like example H above, the answer to that problem with the correct number of single figures is only 150. It didn't even change. Next one, we've got addition and division, so we need to do this in the parentheses first. Calculator says this. We have to remember we're doing addition. Least accurate place value here is the 10th. Here's the 1000th. So we have to round this to the nearest 10th. So we look at the 0, the number behind is a 9, so this part right here is a 31.1. And now we need to divide it by 95.5. 95.9, sorry. The 31.1 has 3 total significant figures. The 95.9 has 3 total significant figures. We're doing division. So we have to round this to 3 total significant figures. The 0 here is a placeholder, so it's 1, 2, 3. To the 4's place, we look behind, it's a 2. So we would report as a 0.324. This next one, we've got subtraction, division, and addition. We have to do what's in the parentheses first in both sides. So the 92.342 minus 32.52. Your calculator says this. We need to look at our numbers. This is accurate to the nearest thousandth place. This is accurate to the nearest 100. So our answer can have 2 decimal places. So there's a 2, and then we look behind, that's another 2. So if this piece becomes 59.82, and then we have to do the same thing here, 283.2 plus 242. This is accurate to the 10th place. This is accurate to the 1s. So we have to round it to the nearest 1. So there's the 1's place. We look at the 2 there. That gets truncated. So it's 525. Now we're division. We have to shift gears. Now we're not concerned about the least accurate place value. We're looking at the least number of total significant figures. This has 4. This has 3. So we can only have 3 total significant figures. 1, 2, 3. Look at the number heights at 9. So this 3 gets bumped up to a 4. 0.114. Lastly, we've got addition here, multiplication, and then subtraction here. We need to do what's in the parentheses first. 0.92 plus 8.52. Accurate to the nearest, 100th or 2 decimal places. This is accurate to 2 decimal places, so we can leave this with 2 decimal places. This becomes a 9.44, and that is going to be multiplied by this 34.23 minus 23.8. 2 decimal places here, 1 here, so your answer here can only have 1. That becomes a 10.4. But this has 3 same figures, this has 3. And we're multiplying now, so we can just take 9.44 times 10.4. And we have to round this to 3 total significant figures. 1, 2, 3. We look at the 1, look at the 7 behind it. We're going to bump this up to a 2. So it's a 98.2. Okay? Hopefully this gives you some good info for this. We'll get some more practice on some in-class worksheets.